Recently, I've been working on a brand new micro SaaS, and I've been having a lot of fun doing so. One thing that I've really appreciated is how easy it is to now deploy our applications to the cloud, with a huge number of platforms as a service making it easy to do so. Whilst these platforms can be pretty great, they're not always perfect. Because of the underlying business model, they're not well suited for long-running tasks, or transferring a lot of data, and doing so can sometimes result in an unexpectedly high bill. This contrasts to using something such as a VPS, which stands for a virtual private server. These often provide much more consistent billing, whilst also mitigating some of the caveats that comes from using a serverless platform. Despite these benefits, however, I've always been rather hesitant to use a raw VPS when it comes to deploying my production services. This hesitancy is due to the perceived difficulty of setting up a VPS to be production ready. But is that actually the case? Well, in order to find out, I decided to give myself a challenge. A challenge to see how difficult it would be to set up a production-ready VPS from scratch. As it turns out, it's actually a lot easier than I thought. To go along with this challenge, I've built a simple guestbook web app with the goal of having it deployed on a VPS. Before I went about deploying this, however, I decided to write out a list of requirements in order to define what production-ready meant. To kick off these requirements, I first wanted to make sure I had a DNS record pointing to the server, followed by making sure that I had the application up and running. Afterwards was adding good security practices to the box, such as making sure that all HTTP communication took place over TLS, and that the box itself would automatically provision and renew its certificates. As well as TLS, there would also need to be additional security measures in place, such as hardening OpenSSH to prevent unauthorized access, whilst also setting up a firewall to block any unnecessary ports. In addition to ensuring that the application was secure, I also wanted to make sure that the deployment had a good user experience. This meant setting up high availability, as much as you can on a single node. To do this, I would need to set up a load balancer so that I could distribute traffic across multiple instances in case one went down. As well as a good user experience, I also wanted to make sure I had a good developer experience. This meant setting up automated deployments, so that whenever I pushed up a change, it would automatically be deployed onto the VPS within a couple of minutes, all whilst keeping the service available. Lastly, I wanted to make sure that if the website did become unavailable at any point, I would be notified. This meant I would need to set up some sort of website monitoring. With my requirements defined, the next thing to do was to consider some of the technical approaches I could take. The first condition I had was that I wanted to achieve this using simple tooling that didn't require too much domain expertise. This ruled out using something such as a lightweight Kubernetes deployment, such as K3s or micro K8s. Additionally, I didn't want to use a full-featured solution, such as Coolify. Instead, focusing on setting this up without any additional layers of abstraction. This also meant I didn't want to use any infrastructure as code, such as Terraform, Pulumi, or OpenTofu, although I may consider migrating to one of these in the future. With my requirements and technical considerations defined, it was now time to start setting up my production environment, which meant I needed to obtain a VPS. Fortunately, that's where the sponsor of today's video comes in, Hostinger, who have kindly provided a VPS instance for me to use throughout this video. If you're considering getting a VPS for your own applications, then Hostinger has some amazingly affordable rates. In my case, I have an instance size of KVM2, which has 2 vCPUs and a whopping 8 GB of memory, costing only $6.99 a month when you sign up for a 24-month contract. It also comes with up to 8 TB of bandwidth a month. If you tried to transfer this much data on Vercel, it would end up costing you over $1,000. Not only this, but a VPS instance this size for $6.99 a month is incredibly affordable, especially when you compare it to other options. Additionally, when checking out, if you use my coupon code DREAMSOFCODE, then you'll receive a further discount on the already low price. So to get your own VPS instance today, make sure to check out the link in the description below and use my Dreams of Code coupon code. After obtaining the VPS instance from Hostinger, I was then prompted to set it up using the Hostinger UI. The first thing to do was to choose an operating system template for my server. Here I had a choice between plain operating systems with panels, or applications. The application tab provides a number of pre-configured environments with specific commonly used applications already installed. These include Docker, Ollama, and even one for VS Code, if that's more your vibe. Whilst this is pretty cool to get started quickly, in my case, however, I wanted to install everything I needed from scratch. So I ended up going with a base operating system installation. As for which operating system, as much as I'd have loved to use Arch, by the way, instead I decided to use Ubuntu 24.04, which is an LTS or long-term support distribution, and perhaps one of the most common operating systems when it comes to setting up a VPS. On the next screen, I made sure to disable the Monarch's malware scanner, as I wanted my server to be as base as possible. Then it was time to set up a strong password for the root user, before adding in an SSH public key to allow me to log in over SSH. Hostinger does provide some instructions on how you can both generate and add a new SSH key. However, in my case, I decided to use my existing one, as it's tied to my YubiKey. This was done by first copying the public key to my clipboard using the following command, and then pasting it into the SSH key box. With everything set up, I went and deployed my new VPS instance, and waited for it to start before testing the login over SSH, which was working correctly. Whenever I log into a new VPS, the first thing I do is to always make sure to add a new user account, as working as the root user is generally not advised. Adding a new user account is done by using the add user command, followed by passing in the user's name. In my case, I set this to be Elliot. Upon doing so, it then prompted me to add the user's password and to fill out any additional information, before then creating the user. With my new user account, the next thing to do was to ensure that this user also had sudo permissions, so that I could elevate its access whenever I needed to. This was achieved by using the following usermod command, adding the user to the sudo group. Afterwards, I could then test that everything was working correctly by first switching to this new user using the su command, before running a test sudo command. With my user account added to the VPS, it was now time to move on to my first requirement, pointing a DNS record at the server. Surprisingly enough, I didn't have any spare domain names lying around, so I needed to purchase a new one. Fortunately, you can buy a domain name from Hostinger at an incredibly low price, so I decided to purchase the zenful.cloud domain name for the low price of $1.99 for the first year. Once the purchase went through, I then went about adding a DNS record pointing to the VPS, using the Hostinger UI. To do this, the first thing I did was clear both the existing A and C name records that were automatically generated, as they were no longer needed. Then I was able to add a new record for the root domain, pointing this to the IP address of my server, which you can pull out of the actual node itself by using the ipadder command. All that then remained was to save the record and wait for it to propagate across the global DNS network. This can take a few hours, so whilst I waited, I went about making myself a warm beverage before deciding to add some more security to the VPS. If you're following along at home, you may want to install Tmux on your VPS and work inside of it. By doing so, if your SSH connection happens to drop, you're able to easily reattach to the Tmux session when you SSH back in. In my case, I'm using Tmux on my local machine with a pretty reliable internet connection. But if SSH did drop, then this can be a little annoying. However, it didn't do so during the filming of this video, which took place over a couple of days. If you want to learn more about Tmux and how to use it, I actually have another video on it, which you can check out after this one. In order to harden the VPS, the first thing I wanted to do was to remove password authentication on SSH, which generally isn't a good idea to leave enabled, as there are many automated bots out there performing SSH brute forcing. Before I was able to do that, however, I first needed to make sure that my non-root user also had a copy of my SSH public key. The easiest way I find to do this is to use the SSH copy ID command from my local machine. This command requires existing authentication in order to copy the SSH public key, so I had to run it before disabling password auth. With my SSH public key copied over, I then tested that everything was working by SSHing in, which allowed me to log in using key-based auth. Now I was ready to disable password authentication. To do so, I first opened up the sshd config file using vim, then changed the yes value of password authentication to no. Whilst I was in this file, I also disabled the ability to log in as the root user, and disabled PAM authentication as well, which are both recommendations for hardening SSH. Additionally, on Hostinger, there was another file called 50.cloud init, where password authentication was also set to enabled, so I needed to either modify this file as well, or just remove it. To apply these changes, all I had to do was first reload the SSH service. Then I tested that everything was working correctly by first running the following command to make sure I couldn't log into the root user at all. With that, my VPS was now hardened from SSH attacks. especially password brute forces. One additional approach that you can take is to change the port that SSH listens on from port 22 onto something else. This can help to reduce the attack surface from automated scanners. However, personally, I feel like this is more security by obscurity. So in my case, I decided to leave SSH on the default port of 22. If you do decide to change this, however, then make sure to take note of it, as you'll need to make some other changes later on. Once SSH had been hardened, I then used NSLookup to check if the DNS record had propagated, which showed me that my zenful.cloud domain name was now resolving to the VPS's IP. I then confirmed this by using the domain name to SSH in. With my DNS record set up, the next requirement was to get the web application up and running. As I mentioned before, I had built a web app to go along with this project, which is a simple guestbook application written in Go where visitors to the website can leave a, hopefully nice, message. If you want to deploy this project yourself or are just interested in the code, then you can find a link to the GitHub repo in the description down below. To get it running on the VPS, I decided to first take a naive approach, which was to clone down the project onto my Hostinger instance and build it. In order to do so, I first needed to install the Go compiler, which was done through Snap using the following command. Once the Go toolchain was installed, I could then build the project using the go build command, which did take a little bit of time, but was fortunately much quicker than, say, if I'd been using Rust. After it was built, I then had a binary called guestbook, which I could then run. However, this unfortunately failed, as the application needs a database URL environment variable in order for it to connect to a Postgres database in order to store the data. Later on, I actually set up an instance of Postgres on the VPS, which makes a lot of sense given how much memory it has, coupled with the fact that Hostinger also provides 100 GB of SSD storage. In a true production environment, however, there's a lot more you need to do when it comes to setting up a database. Just keep that in mind. Before installing Postgres on the VPS, however, I first decided to test that the app was working by setting the database URL environment variable to a spare Postgres instance I had lying around. Then I ran the app again, which this time showed that the server was listening on port 8080. To test that everything was working, I opened up a web browser to the zenful.cloud domain at port 8080, which brought me to my application's homepage. So far, so good. Whilst this approach of cloning down the repo and building it on the box does work, personally, I'm not a big fan of compiling applications on my production server. Instead, I prefer to use containerization, which allows me to build an immutable image of my application for distribution, which also happens to be versioned and configurable. This means rather than running the application binary directly, instead I decided to run it using Docker through a Docker image. This project comes with a Docker file in it already, which you can view on GitHub. Additionally, I also had built and pushed a Docker image to the GitHub container registry, found in the project's packages. In addition to this, the project also contains a compose.yaml, which allows me to easily use Docker Compose to deploy this project, as well as any other dependencies, such as Postgres, which also has a service reference inside of the compose file. This meant I could use Docker Compose to deploy the entire production-ready application stack. In order to do so, however, I first needed to install Docker and Docker Compose onto the VPS. The best way to do this is to follow the instructions found on the Docker website, which gives a list of commands to enter. These commands add the Docker repository to apt, which allows you to install both Docker and Docker Compose plugin via the apt install command. Once these had both been set up, the Docker service was now up and running. However, if it's not in your own case, you can go ahead and run the following system control commands in order to enable it. The next thing to do was to then add the user to the Docker group by using the usermod command. This prevents the user from needing to use sudo in order to interface with Docker. Next, it was time to get the application stack deployed. In order to do so, I first needed to set up a password for my Postgres instance. Rather than hard coding this into the compose.yaml, I decided to instead set this using a Docker Compose secret, which is defined on the following line. To do so, I needed to write out my password into the specified file, which was done by first creating the db directory using makedir, followed by echoing the password into the file using the following command. Then I could go ahead and deploy my stack using the Docker Compose up command, which began by creating an instance of Postgres, followed by creating an instance of the guestbook service. Now, when I headed on over to a web browser and typed in the zenful.cloud domain name, followed by port 8080, I was greeted by a running instance of the guestbook web app, as well as seeing a corresponding line in the container logs. With that, I had my containerized service running with a domain name pointing to it, which meant I had completed 3 of my 8 requirements. The next production-ready step on my list was to enable a firewall, Whilst this is generally a good idea to improve your VPS security, I did run into a slight caveat when doing so, which I'll talk about in a bit. To set up a firewall for this server, the only ports that I wanted to be enabled were the Open SSH ports, which was port 22 for me, the port for HTTP, which is port 80, and port 443, which is used for HTTPS. To achieve this, I decided to use the simple yet powerful UFW application, which stands for Uncomplicated Firewall. Not only is UFW really simple to use, but it also comes installed by default on Ubuntu distributions, making it a great choice for this VPS. In order to use it, I began by defining the firewall rules. The first of which was to disable all inbound network requests by default, which was done using the following command. Next, for all outgoing requests, I enabled these by default, using this next command. Lastly, I then needed to enable inbound requests to the Open SSH server, so that I was still able to SSH into the VPS. Just to be aware, this is a really important step. If I had forgotten to do this, then I'd no longer be able to access the VPS, so it's really important to get this right before enabling the firewall. To allow connections to the Open SSH server, I used the following command, which allows any inbound traffic to port 22. If I had changed the SSH port to be something else, such as 800 however, then I would have needed to use the following command instead. With that, I did one last check to make sure that I had configured the firewall correctly, and then enabled it by running the following UFW enable command. With that, the firewall was now up and running. However, when I went and checked if the website was still accessible, it actually was, despite being on a port I hadn't explicitly allowed. This was the caveat that I mentioned earlier, and is caused by the fact that exposing a port with Docker will actually overwrite the IP tables rules defined by UFW. This is unfortunately a well-known issue, and whilst there are some workarounds, there's not really one great solution. One such workaround is to only expose the port on your loopback IP address of 127.0.0.1 by using the following syntax. And whilst this does work, it's not exactly ideal. Instead, the best way that I found to make sure that these ports aren't exposed is to just not define them in the Docker Compose file. But then, how can anyone access the web application on port 8080? Well, the best way to do that is to set up a reverse proxy, which is what will be exposed onto the internet instead. In the past, I've typically used Nginx as my go-to reverse proxy. However, this time, after doing some research, I ended up going with another option. Traffic, which is confusingly spelt as Trafic. Spelling issues aside, Traffic is pretty awesome, and was probably one of the two biggest reasons as to why setting up this production-ready VPS was much easier than I thought it would be. To begin setting up the reverse proxy, I wanted to make sure I had traffic listening on port 80, forwarding any HTTP requests containing the zenful.cloud host header to my guestbook service. In order to add traffic to the stack, I added a new service into my compose.yaml called reverse proxy, pointing it to the traffic image with tag 3.1, followed by passing in 2 arguments to the command field. Then I specified the ports of 80 for HTTP and port 8080 for the web UI, so that I could access the traffic dashboard for debugging. The last thing to add was to set the Docker socket as a volume for the container, so that traffic can listen to any Docker events, such as new services being spun up, and is why traffic works really well with Docker Compose. With the new service added, I then restarted Docker Compose and added both port 80 and 8080 to the UFW allow list. Whilst this step may not be required due to the fact that Docker was overwriting the IP tables, it was worth playing it safe in my opinion, just in case there were any race conditions between the two services writing to the IP tables. To test that everything was working, I opened up a new browser window and headed over to zenful.cloud, where I received a 404 not found. Whilst this is an HTTP error code, it showed me that traffic was set up correctly, which I could then confirm by heading on over to port 8080, which brought me to the traffic web UI dashboard. Upon confirming that traffic was working, the next step was to set it up so that the HTTP requests would resolve to the guestbook service. I achieved this by adding in the following line to the guestbook service inside the Docker Compose file. This line adds a label to all the guestbook Docker containers, telling traffic to route any HTTP requests that contain the zenful.cloud host to this service. Because traffic listens to events on the Docker socket, then this was all I needed to do in order to set up reverse proxying. Pretty simple. After redeploying Docker Compose, I was then able to visit the Zenful Cloud domain in my browser, and it now resolved to my guestbook web app. With that, traffic was now working as my reverse proxy. and my DNS record was now resolving to the guestbook web app. But Trafic's abilities don't just stop there, and I was able to use it to mark off another requirement on my checklist, setting up a load balancer. To show this in action, I first scaled up the number of guestbook instances I had to 3 replicas, using the following docker compose command. Then when I went and refreshed the page a number of times, I could see in the logs that each of the requests were being balanced across the 3 instances. All of this was being handled under the hood by Trafic, without needing to add in any additional configuration. This is really nice. Now, you may be thinking, what's the point of a load balancer on a single node, as it doesn't exactly improve performance? Whilst this is the case, it does do something else, however, which is improves the reliability of the service through increased availability. For example, if one of the guestbook server instances goes down due to, say, a panic, Trafic can then route the requests to the other 2 services whilst the failing instance comes back online. This helps to improve the overall user experience, keeping availability high, and therefore having 3 instances up and running is usually a good idea, especially as it doesn't cost anything extra, given how much memory we have on this VPS. So in order to make this change persistent, I added in the following replicas block to the guestbook service in the docker compose file, which also meant I could now check off the load balancer from my production-ready requirements. As well as load balancing, Trafic also produces another feature that is on our list, TLS certificates. In the past, I've typically achieved this for Nginx using Let's Encrypt with Certbot, which is a service that both obtains certificates and automatically renews them for you. For this VPS, however, I didn't need to use it, as Trafic already has this functionality built in. As I mentioned before, Trafic is really doing a lot of the heavy lifting when it comes to this production-ready VPS. In order to enable automatic generation of TLS certificates, all I needed to do was add in the following lines into the reverse proxy services command list. The first line prevents any Docker containers from being exposed by default. This means that in order for Trafic to expose a service through its proxy, the service will need an explicit label added to it. Next, I then defined an entry point called Web Secure, pointing this to port 443, which is the port used for HTTPS. Underneath this, I then added in the necessary arguments to define a certificate resolver called myResolver in order to generate the TLS certificates. The first of these arguments defines the challenge type, which in my case was TLS. Next, I defined the email address to be associated with the certificate request, followed by the location of where to store the certificate data. Afterwards, I then replaced the reference to port 80 with port 443, meaning that the load balancer would only be accessible over HTTPS. Lastly, I then defined a volume mapping of Let's Encrypt to the /Let's Encrypt directory of the container, before adding in 3 more labels to the guestbook service. The first of these is the explicit label to enable Trafic to proxy to this service, which was now needed given that I had just disabled automatic exposure. The next label told Trafic that as well as needing the host of zenful.cloud, requests would also need to come in on the web secure port, i.e. port 443, in order to be routed to this service. And the third and final label told the router to use the certificate resolver that we just defined. The last thing I needed to add to this file was to define the Let's Encrypt Docker volume that I was using to store the certificate data. With everything added in order to configure TLS, I restarted the Docker Compose and waited for about 5 minutes for the certificate request to take place. Once it was completed, I was then able to access my guestbook over HTTPS. Unfortunately, however, this setup did have another issue. Because I had disabled the HTTP port, I could no longer access the website by using its domain name on the browser, which by default will attempt to resolve to the HTTP protocol on port 80. Because of this, any attempts would eventually result in a timeout. To fix this, I needed to set up an HTTP redirect, which would redirect any HTTP requests on port 80 to HTTPS, i.e. 443. In Trafic, this is done by adding in the following 3 labels, as well as adding in port 80 back into the port list. Now, when I tried to access my website using HTTP, it would automatically redirect me to HTTPS. With that, I had managed to check off another item off my requirements list, and the next production-ready feature to add was automated deployments. The goal of this requirement was to make it so that whenever I pushed up a change, be it either a code change via Git or a new Docker image, the VPS would automatically pull down the new version of the app and redeploy the services. Initially, I was expecting this to be the most challenging feature, especially as there's a number of different ways to achieve this. Fortunately, the approach I decided to take was rather simple. That approach was to use a service called Watchtower, which works really well when it comes to Docker Compose. Watchtower works by watching for any images that are defined in your Docker Compose services. Then, when it detects that a new version of the image has been pushed, it'll pull down this image, update the containers, and restart any associated services. In order to set this up, I added in the following Watchtower service into the Docker Compose, with the following 3 command arguments. The first of which was the label enable, which enforces the use of a label in order to explicitly define which services Watchtower should monitor. The next 2 lines is the argument of interval followed by the parameter of 30, which specifies the interval time in seconds that Watchtower should poll for new services. In my case, I set this to be 30 seconds. Next, just like with traffic, I also needed to define the Docker socket as a volume for this service. This is used by Watchtower to perform any Docker-based actions. Now all that remained was to scroll down to the guestbook service and add in the following label, which would enable Watchtower to monitor it. As well as this, I also had to make another change to explicitly set the Docker image tag of the guestbook service to be prod. This is because Watchtower only monitors for image changes with the same image tag, so in order to trigger a redeploy, I would need to push a new version of that image with the same tag. In this case, prod. Normally, this isn't my preferred way of tagging Docker images. Instead, I much prefer to keep these immutable, as there are a number of benefits to doing so. With that being said, Watchtower is incredibly easy to get automated deployments set up. So in this case, I decided to not let perfection be the enemy of done. With Watchtower configured, the next thing to do was to restart Docker Compose, followed by testing the automated deployment capabilities. To do so, I made a quick change to the index page of the guestbook application, before building and pushing a new image to the GitHub container registry. Then, through watching the logs, I could see that Watchtower detected the new image, pulled it down, and restarted the containers. Opening up the web page in a browser, I could then see that the new version was deployed and my changes were now live. With that, I had a basic automated deploy system in place, one that I could easily expand out to a CI/CD pipeline using GitHub Actions. However, when testing this solution, I did notice one issue. Whilst watching the logs, I noticed that the default behavior of Watchtower was to first pull down a new image, stop all the running containers, before then starting them back up again with the new version. This meant that there was a brief window of time where none of the containers were running, and if a user tried to hit the service at this time, they would then receive an error status code. This deployment behavior isn't one I would consider as production ready, as it produces the possibility of a bad user experience when the system redeploys. Fortunately, Watchtower does provide support for rolling releases, which is where each service is updated one after the other, rather than updating them all at the same time. To enable this with Watchtower is as simple as passing in the -- rolling restart flag. Now, when I push up a change, if you check the logs, you can see that this is done in a rolling release way, restarting each of my instances one by one. With that, my VPS server was almost in a production-ready state. The final requirement on my list was to make sure that if something went wrong and my website was down, I would be notified of it. One way to do this in a typical production environment is to use observability, which means collecting logs, metrics, and traces and storing them in an associated database, such as using Prometheus when it comes to metrics, or using the Elk stack when it comes to logs. All of this would end up requiring a lot more infrastructure. So instead, for my single node VPS, I decided to use a simple uptime monitor. These work by periodically checking if a website is available, and will send a notification if they detect an error. There's a number of different uptime monitors out there, but the one that I decided to use was Uptime Robot, which has a pretty decent free tier. To do so, all I needed to do was pass in the URL to Uptime Monitor, and it would begin monitoring my service. Now, if my web application happens to become unavailable, Uptime Robot will send me an email notification letting me know. With the monitoring setup, all that remained now was to remove the Traffic Web UI and redeploy the Compose stack, using the -d flag to run this in a detached state. With that, I had managed to set up a production-ready VPS to use with my server. Whilst it may not be as simple as using a platform as a service, it certainly wasn't as challenging to set up as I initially thought. In fact, I'm really happy with how this turned out, and by using tools such as Traffic and Watchtower, I was pleasantly surprised by the amount of functionality you can easily set up in a short amount of time. I want to give a big thank you to Hostinger for sponsoring this video and making the whole thing possible. If you're interested in obtaining your own VPS, then I recommend checking them out using the link in the description down below. If you do, make sure to use the coupon code DreamsOfCode for that additional discount. Otherwise, a big thank you for watching, and I'll see you on the next one.